Dear students, today we will be starting indefinite integration of 10 selected sums. The sums are number 1 sin x by root over 1 plus sin x dx. Number 2 x square plus 1 by x to the power 4 plus 1 dx. Number 3 integration e to the power 3x sin 4x minus 2 by 1 minus cos 4x dx. Number 4 2x tan inverse x square 1 plus x to the power 4 dx. Number 5 root over tan x dx 6 dx by e to the power x minus 1 dx. Number 7 1 by log x minus 1 by log x whole square dx. Number 8 sin 2x by a square sin square x plus b square cos square x dx. Number 9 x log x whole square dx. And number 10 dx by 2 sin square x plus 3 cos square x. Now I will show all sums step by step. This 10 sum frequently asked question of CBSE board examinations. Okay. Now I will solve sum number 1. First you will consider I is equal to sin x by root over 1 plus sin x. It was the sum. So what will you do? First you will add 1 and subtract 1. Okay. Then you will segregate 1 plus sin x by root over 1 plus sin x dx minus dx by 1 plus sin x. Then you will consider that one and the numerator. So it will be 1 plus sin x and denominator is root over 1 plus sin x. So if you simplify, you will get root over 1 plus sin x dx minus dx by root over 1 plus sin x. You consider this is I1 and this is I2. So I is equal to now I1 minus I2. Now separately I will show I1. What was I1? I1 was 1 plus sin x dx. Can we write instead of 1 sin square x by 2 cos square x by 2. Look, this one represent only that one. And then sin x. Sin x formula 2 sin x by 2 cos x by 2 dx. So look, a square, b square, 2ab. That means we can write sin x by 2 plus cos x by 2 whole square dx. Under square root square, that means square root will remove. So this will be sin x by 2 cos x by 2 dx. Is it okay? Can I change the slide? Okay, thank you. Now you can segregate. This is sin x by 2 dx plus cos x by 2 dx. So this is minus cos x by 2 then 1 by 2 plus sin x by 2 1 by 2 plus c plus c plus c. You have to write plus c, otherwise marks will be deducted. So minus 2 cos x by 2 plus 2 sin x by 2 plus c. You can consider c1. This is c1. That is the final of I1. This is the final of I1. Is it okay? Is it okay? Now we will show the second part of this sum, I2. What was I2? I2 was dx by root over 1 plus sin x. Same process you will follow. So you will write dx, you will write dx by within square root sin x by 2 plus cos x by 2 whole square. Under square root whole square, that means square root will remove. So this will be sin x by 2 plus cos x by 2. Okay. Okay. Now we will multiply 1 by root 2 to the numerator and 1 by root 2 to the denominator. So sin x by 2 into 1 by root 2 cos x by 2 into 1 by root 2. We multiply with 1 by root 2 and divide with 1 by root 2 to each term. Okay. Now 1 by root 2 dx by sin x by 2. Can I write this one cos pi by 4 plus cos x by 2 sin pi by 4. Sin A cos B, cos A sin B. So we can write 1 by root 2 dx by sin x by 2 plus pi by 4. Is it okay? Now 1 by sin is nothing but cosec. So this will be 1 by root 2 cosec x by 2 plus pi by 4 dx. Now directly you can use the formula. So 1 by root 2 log tan x by 4, because cosec x is log tan x by 2 plus the whole one is pi by 8. So this will be plus c2. I will write c2 and there have 2. So I will write down that is 2. This 2 and that will cancel root 2. So this will be root 2 log tan x by 4 pi by 8 plus c2. This is the solution of second part. So what will be the concluding line? Concluding line will be I is equal to I1 minus I2. Just write down the solution of I1. I1 was 2 sin x by 2 cos x by 2 plus c1, and this is root 2 log tan x by 4 plus pi by 8 plus c2 plus c2. Final line you will write I is equal to 2 sin x by 2 minus cos x by 2 minus root 2 log tan x by 4 plus pi by 8 plus c. Previously it was c1 and c2. Finally you will write only c. You should write where c is any arbitrary constant. This is the solution of the first sum. Sum was x square plus 1 by x to the power 4 plus 1 dx. This is very important sum. We will divide numerator and denominator by x square. So this will be x square plus 1 by x square and x to the power 4 plus 1 by x square dx. You can write, you can skip, no issue. For better understanding, I wrote there. So 1 plus 1 by x square dx, and denominator will be x square plus 1 by x square. Here we will use a square plus b square formula. A minus b whole square plus 2ab, that formula we will use in the denominator. So 1 plus 1 by x square dx by that one will be x minus 1 by x whole square plus 2 into x into 1 by x. So this will convert it to 1 plus 1 by x square 1 by x square dx by x minus 1 by x whole square plus 2, putting x minus 1 by x is equal to t. Look that step. If this is minus, so we will get that is plus. If this is plus, we will get that one minus. So according to that, we will change the formula. So this one 1 plus 1 by x square dx is equal to dt. We get integration dt by t square plus 2. That means dt by t square plus root 2 whole square. So now we will use the formula. This is 1 by a tan inverse x by a. So 1 by a, then tan inverse t by root 2 plus c. So question was in the form of x, so we have to convert t in terms of x. So this is x minus 1 by x by root 2 plus c. This is the answer of the second sum. Now this is the answer of the second sum. Now we will move to solution of sum number 3. What was the sum? Sum was e to the power 2x sine 4x minus 2 1 minus cos 4x dx. Here putting 2x is equal to t. So we will get 2 dx is equal to dt. That means dx can changes by dt by 2. Now after changing that, we will get this is e to the power t, then sine, this is 4x, we consider 2x is equal to t, so it will be 2t minus 2 and 1 minus that 4x will convert it to cos 2t dt by 2. So we can write 1 by 2 e to the power t sine 2t minus 2 1 minus cos t 2t dt. Okay. Now I will use the formula of sine 2t. Half e to the power t, I will write down 2 sine t cos t minus 2, and denominator is this formula I will use 1 minus cos 2t is equal to 2 sine square t. This formula I will use in denominator. So 2 sine square t. Okay. Now from the numerator and denominator 2 will be cancelled. I will show that one also. So 2 sine t cos t minus 1 by 2 sine square t. So these 2 will be cancelled. So what will I get? I will get 1 by 2 e to the power t cos t sine t minus 1 by sine square t dt. Okay. Now we will segregate sine square t with that one and this one. So I will change that 1 by 2 sin t cos t by sin square t dt minus dt by sin square t, and for that part e to the power t and e to the power t also present. So I will write 1 by 2 e to the power t. This one will be sin t, that means cot t, plus this is sin square, so it will be cos square t, before that minus sin, okay. So I will change that one. How will I change? I will change that one 1 by 2 e to the power t cot t dt minus e to the power t cos square t dt. Now I will split that one, first term and second term. So how will I proceed? I will write down 1 by 2, this is e to the power t cot t dt minus e to the power t cos square t dt. This is the first function and this is the second function. I will split that one and second term will remain intact. Is it okay? Now I will change 1 by 2. This is the first function, this is the second function. So what will I write? Cot t e to the power t dt minus d dt of cot t integration e to the power t dt, then dt minus e to the power t cos square t dt. Okay. Now I will write 1 by 2 cot t e to the power t plus e to the power t cos square t dt minus e to the power t cos square t dt. So these two will be cancelled. So we will get I is equal to 1 by 2 cot t e to the power t plus c. Therefore I is equal to 1 by 2 cot 2x e to the power 2x plus c. This is the answer of sum number 3. Now I will show sum number 4. I is equal to 2x tan inverse x square 1 plus x to the power 4. Putting t is equal to tan inverse x square. So dt is equal to 1 by 1 plus x square whole square into d dx of x square. So this is 2x into dx. Okay. So we get, after doing that, we get I is equal to t dt, that means t square by 2 plus c. Therefore I is equal to 1 by 2 tan inverse x square then whole square plus c. This is the solution of sum number 3. Now we will switch over to the sum number 5. What was the sum number 5? Sum number 5 was root tan x dx. Now putting tan x is equal to t square. So sec square x dx is equal to 2t dt. So we can write, instead of sec square, 1 plus tan square x dx is equal to 2t dt. Now we can write dx is equal to 2t by, I will write instead of tan square t to the power 4. So 1 plus t to the power 4 dt. After doing that, we get I is equal to root tan square 2t by 1 plus t to the power 4 dt. So this is 2t square by t to the power 4 plus 1 dt. Now I will adjust 2t square in this way. I will write t square plus 1 plus t square minus 1. Denominator will remain intact. Now I will segregate this one and that, second one by that. So how will I change? I will write down t square plus 1 by t to the power 4 plus 1 dt plus t square minus 1 by t to the power 4 plus 1 dt. Now I divide numerator and denominator for both part by t square. So what will I get? 1 plus 1 by t square dt, and denominator will be t square plus 1 by t square for the first part. For the second part, same, divide numerator and denominator by t square. So 1 minus 1 by t square plus 1 by t square dt. Okay. Now already I told, according to requirement of the numerator, I will change that. I know a square plus b square is equal to a plus b whole square minus 2ab, or a minus b whole square plus 2ab. According to requirement of the numerator, we will take first one or second one. So this thing you should keep in your mind. Look, for the first part, as 1 plus 1 by t square in the numerator, so denominator I will write t minus 1 by t whole square plus 2, and for the second part, as 1 minus 1 by t square in the numerator, so denominator will be t plus 1 by t whole square minus 2. Because when you will differentiate that one, you will get the numerator. When you will differentiate the second part, you will get the first one. Okay. So for the first one, you will putting t minus 1 by t is equal to u for the first part. So you will write 1 plus 1 by t square dt is equal to du. And for the second part, t plus 1 by t, you will consider v for the second part. So you will write 1 minus 1 by t square dt is equal to dv. Okay. For this one for the second part, and that one for the first part. Okay. So I will change the slide and I will write down the remaining portion. I is equal to du by u square plus 2 plus dv by v square minus 2. Now we will slight change u by u square plus root 2 square and then dv by v square minus root 2 square. So this will be two formula. For the first one, 1 by root 2 tan inverse u by root 2, and for the second one, 1 by 2a log x minus a by x plus a. So 1 by 2 root 2 log v minus root 2 by v plus root 2 plus c. So question was in the form of x. So you should change the u and v in terms of first t, then x. So you will write 1 by root 2 tan inverse t square minus 1 by root 2t plus 1 by 2 root 2 log t square minus root 2t plus 1 by t square plus root 2t plus 1 plus c. So this is 1 by root 2 tan inverse tan x minus 1 by 2 tan x plus 1 by 2 root 2 log tan x minus 2 tan x plus 1 by tan x plus 2 tan x plus 1 plus c. This is the answer of the fifth sum. Okay. Now I will show sum number 6. Solution of sum number 6. I is equal to dx by e to the power x minus 1. So many process to solve this sum, but here I will multiply numerator and denominator by e to the power minus x. E to the power minus x. So I will get that one. Okay. Now putting 1 minus e to the power minus x is equal to t. So e to the power minus x dx is equal to dt. Okay. Then we get I is equal to dt by t. So this is log t plus c. So this is log e to the power minus x plus c. So minus x log e plus c. So this is minus x plus c. I is equal to. This is the solution of sum number 6. Okay. Now I will solve sum number 7. I is equal to 1 by log x minus 1 by log x whole square dx. That was the sum. I will write 1 by log x dx minus dx by log x whole square. That one I will write log x to the power minus 1, then 1 dx minus dx by log x whole square. This is the first function and that is the second function. I will split according to that. So what will I get? I will write log x to the power minus 1 dx integration d dx of log x to the power minus 1 dx, then dx, and the last term intact dx by log x whole square. If I simplify, I will get log x to the power minus 1 into x minus x by log x whole square into 1 by x dx plus dx by log x whole square. This will be plus because there had minus, and this is minus will remain intact. If I simplify, I will get x by log x plus dx by log x whole square minus dx by log x whole square. These two will be cancelled. Therefore, I is equal to x by log x plus c, where c is any arbitrary constant. Now I will show sum number 8. Sum number 8 was I is equal to sine 2x by a square sine square x plus b square cos square x dx. Putting a square sine square x plus b square cos square x is equal to t. Now differentiate a square 2 sine x cos x b square 2 cos x sin x. That time I will get one negative sign, that is why it will be minus, then bracket dx is equal to dt. Now these two are same, we can write a square sine 2x minus b square sine 2x dx is equal to dt. Now sine 2x common, so a square minus b square sine 2x dx is equal to dt. So sine 2x dx is equal to dt by a square minus b square. After doing that, we get I is equal to 1 by a square minus b square dt by t. So 1 by a square minus b square log t plus c. Question was in that form of x, so we have to change from t to x. So a square minus b square log a square sine square x plus b square cos square x plus c. This is the solution of sum number 8. Now we will show sum number 9. What was the sum? Sum was I is equal to x log x whole square dx. I will consider this into 1. This into 1. This is the first function. This whole thing is the first function. That is the 1 is the second function. So I will write x log x whole square dx minus d dx of x log x whole square dx again dx. So what will I get? X log x whole square into x minus differentiation 2x log x, then bracket log x plus x into 1 by x into x for that integration, and after that again dx. After doing that, if I change, I will get this is x cube log x whole square minus integration 2 x log x whole square dx minus 2 x square log x dx. So I is equal to x cube log x whole square. This is the 2 again I, and that is the last part. I can write 2, then this is the first function and that is the second function. So how will I proceed? I will write log x square. There are minus sign, so I will take that minus sign, x square dx minus ddx of log x, then integration x square dx again dx. So if I transpose this 2i to left side, what will I get? I will get 3i is equal to x cube log x whole square minus 2x cube by 3 log x plus 2x cube by 9 plus c1. Therefore, I is equal to 1 by 3 x cube log x whole square 2 by 9 x cube log x plus 2 by 27 x cube c1 by 3. So what will be the final answer? Final answer I will be equal to 1 by 3 x cube log x whole square minus 2 by 9 x cube log x plus 2 by 27 x cube plus c dash, where c dash is an arbitrary constant. Okay, this is the complete solution of sum number 9. Now I will show the solution of sum number 10. I is equal to dx by 2 sine square x plus 3 cos square x. For this pattern, I will multiply numerator and denominator by sec square x. So this is sec square x dx by, we will get 2 tan square x plus 3. Okay. Then putting tan x is equal to t. So what can I write? Sec square x dx is equal to dt. Then we get, in next slide, we will get I is equal to dt by 2 t square plus 3. Now I will take out that 2. So what will I get? 1 by 2 dt by t square plus 3 by 2. To convert into the standard formula form, we will write this is t square plus root 3 by 2 whole square. Now we will put into formula 1 by 2 1 by a tan inverse x by a. This is the formula. So 3 by 2 tan inverse t by root 3 by 2 plus c. So the final answer is 1 by root 6 tan inverse root 2 tan x by root 3 plus c, where c is any arbitrary constant. Thank you. Thank you, students.